Hello students, today we are going to learn about the step response of second order system. Now we know that standard closed loop transfer function of second order system is omega n square upon s square plus 2 zeta omega ns plus omega n square. Now, if we want to put unit step to the system, what type of output we can expect? As we have discussed in class that depending upon the value of zeta, we can classify the poles in 4 sections. And they are going to give certain type of response. We have named it, if the value of zeta is equal to 0, we can get undamped response. If the value of zeta is within 0 to 1, we can get underdamped response. Next, if value of zeta equal to 1, we will get critically damped response. And if the value of zeta is greater than 1, we will get overdamped response. So, if we put step input depending upon the value of zeta, the system parameter, we can expect these 4 type of response. So, that means step response of second order system, this is actually different type of response, this underdamped, undamped, critically damped and overdamped. Now we are going to learn about underdamped initially. So let's proceed for underdamped response. In case of underdamped response, we know the closed loop poles actually is placed, closed loop poles are second order system, we will get 2 closed loop poles, and this closed loop pole position is imaginary with having a negative real part. So the pole position is like this. In this type of system, we are feeding a unit step. We are feeding unit step to the system. So I am not giving the derivation, I am just writing the expression. So what type of expression in time domain we can get? We can write it in 2 forms. One is 1 minus e to the power minus zeta omega n t upon 1 minus zeta square zeta sine omega d t plus 1 minus zeta square cos omega d t. In this way we can write, or we can write it in another form like Ct equal to 1 minus e to the power minus zeta omega n t upon 1 minus zeta square sine omega d t plus tan inverse 1 minus zeta square by zeta. So this is the output expression for the system. What type of system? Now, which is having poles in left half of S-plane with certain real and imaginary parts. And if we put unit step to this system, we can expect this type of response. Now, what this type of response actually means? You can notice that in this section we are getting that a sinusoidal sin omega t plus theta expression. That means it's a sinusoidal. We can express it as a sinusoidal response, but it is always multiplied with this factor. This is an exponential factor. So we try to draw the diagram. What we find, if we try to draw the diagram, so that means this part will give us a sinusoidal response. With certain angle. So it will be like a sinusoidal expression, and if I think of this factor, it is multiplied with this factor as well as this factor. If I think of this factor, this is an exponential curve. Each and every time it is acting on the sinusoidal expression. That means it is like this type of curve is always acting on the sinusoidal expression. This is e to the power minus zeta omega n t. Each and every time it is acting on the expression, that is, it is actually decreasing the magnitude of the sinusoid, and this thing is subtracted from 1. So what is the ultimate expression we can get? It will look like so the ultimate expression, ultimate diagram will become like this. If this, as it is a unit step, this is my input. So the expression, so the diagram or the graph or the response will be look like this. So this is actually underdamped response. Okay. So we know that whenever we are giving a step input to a system which has closed loop poles having negative real parts, it will give us underdamped response. The expression is like this, and the diagram of this is CT, and the response curve will look like this. Thank you.